Alright, so we know that if you take a function and if you were to differentiate it, we get f prime x. If you differentiate again, we get double prime x. When you differentiate it, this gives you the what? This gives you the gradient. Whereas f double prime x, what use does that have? Right, so this gives you a test on the nature of the stationary point. Yeah? And we also know, so imagine this staircase, you're going down, this point here is differentiation. Now the reverse process of going up, we know, is integration. Okay? And that means if you were to integrate f prime x dx, we get fx plus c. So it's a reverse process of differentiation. Now one of the functions this has is actually in finding areas. But before we look at that, let's just see how we find an area, or how it works in terms of finding an area. So far, we've got this constant of integration, okay, plus c. And this covers, as we saw last lesson, it covers a general case. Yeah, it covers for all, it's not a particular case, it's a general solution. Okay? It's a general solution. But we know that you might have a particular solution. So let me show you how, in terms of notation, this would work. So then I've got to integrate 2x minus x squared dx. Okay? When you integrate this, what do you get? So x squared, what happens to the 2? Don't you divide it by the 2? Good. Okay, so those two, just to be clear, yeah, so you divide it by 2 and that cancels, and then you get x cubed over 3. Okay? And normally we would write plus c. Agree? Just to say it's a C or constant of integration, because if you take this equation, okay, and you want to differentiate, you'll end up with this equation here. And that c could be any number. If you take 10, 100, 1,000, million, minus 10, it doesn't really matter. When you differentiate, you'll always end up with that previous equation over there. Okay? But let's take away this plus c and talk about certain limits. Say we had a limit of 1, 2. I'll write this in Z because you don't really need to, in red, sorry, because you don't need to put this in all the time. So you've got x equals 2, x equals 1. That's what it's saying. And now it's not a general solution, it's a particular solution. And what you would do is use square brackets. You might want to copy this down and write 2 and 1. Now watch what happens. You then substitute the 2 in. So you've got 2 squared take away 2 cubed over 3. And you substitute the 1 in. 1 squared take away 1 over 3. And in between them, you always put a minus sign. It's always minus. So I'll add a few notes. You always subtract. Notice the square brackets. It's just a question of notation. And this really means the limits of x. And you can work this out, and you should get, once you show you're working out, you should get 2 over 3. Is that okay?
Yeah.
Once you've copied that down, can you have a go at this question here? Let me just put this in. Okay, off you go. Have a go at working out this integral. If you look at the answers, firstly, make sure you've got the square brackets and you write 10, 2. Once you start the integration process, you shouldn't be using the integral sign. When you do write the integral sign, make sure you write dx. Show you working out, substitute your numbers in, there's your method marks, and then out come your answer, and you get 240. Okay? What I'm going to ask you to do is do another one. Have a go, let me try and put a negative number. Let's have a go at this one. Now while you're doing this, guys, what I'm going to do is to get the Casio calculator up as well. Now on the calculator, the advantage is in an exam, you can check your answer before you walk out. You still need to obviously put your working out in, otherwise you wouldn't get any marks. So you've got 3, we've got -2, and then we can put in 3 and then x for alpha. X gives me a capital X, and that gives me 15 over 2.
So how do you get the sign?
The integral sign, this button here. Okay. So let's have a look. Let's go over it. So we've got 3x squared over 2. Hands up if you got that. And you wrote 3, 2. You substitute your values in. Hands up if you substituted your values in and you showed it as well. Good. And then you should get 7.5. Now, if we were to go back to the equation we started off with, which was this one here, 2x minus x squared. So if you go back to this, let me just get rid of this over here. If we go back to this equation we've got here, 2x minus x squared, and just see what this looks like. And remember our limits are 2 and 1. Okay? So here's 2x minus x squared. Let me zoom in. Okay? And remember the limits are 2 and 1. Now one of the things on GeoGebra is something called a function inspector. If I can click on this, and I can move these points around. So if I go to 1, and I go to 2, there's 2 and 1. Now between this function inspector gives me quite a bit of information about the graph. And it tells me that the area is 0.667. So if I in fact go back, okay, let's just put that in. Okay, that's 2 over 3. Isn't that what we got for the integral? Okay, so the integral is therefore the area underneath the curve. Agreed? Yeah. So that therefore, if you want to work out the area underneath the curve, all you have to do is integrate the curve between the limits that you're interested in. Does that make sense? Yeah. Shall we write that down? I'll type it here. Let's write down the integral between two limits of a function gives us the area between the curve and the x-axis. Well, right now, curve or function and the x-axis. Is that okay for everyone? Yeah, and you can see that here. So we've just demonstrated it. However, let me leave you with this problem. What I'd like you to do is integrate the following function. Let me just put this up. 1 second. Okay. Okay, what I'd like you to do is integrate 3x squared take away 4x between the limits 2 and 0 and tell me what you get. Off you go. Okay, let's investigate. The answer is that yes, you do get 0. Let me just get a rubber and rub that out. Yeah, we should get 0. But let's see what's going on. I can ask you to sketch it, I guess, but I'll save you the hassle. So over here we've got 3x squared. Let's see what's going to happen. So you've got 3x squared take away 4x Okay, here we go. Is that right? 3x squared take away 4x. And the limit is from 2 to 0. So I'm going to squash this in a bit. Okay. And if I use function inspector again, okay, let's see what's going on. So we want from 2 all the way to 0. Okay. Now the area is actually 2.37. That's clear. It's a positive area. But the integral is 0. Let me put that in here so it's part of the notes. Let's take a screenshot of this. Okay. So what's going on then? Yes?
Is it like the area or the integral underneath is maybe a minus and then they're both equal so it cancels out?
Yes, yeah, exactly. Alright, what I'd like you to do, what are the roots of this function? So you've got x equals 0. What's this root here? What would it be? Can anyone see? Yeah, 1/3. So you've got, if you factorize this, you've got 3x take away 4. And for this to equal 0, either x equals 0 or x equals 4 over 3. Correct? Alright. What I'd like you to do is work out, I'll call this area 1. I'll call this area 2. Can you work out area 1? So that should give you 4 over 3. Oops. That should give you 2, from 2 to 4 over 3. And can you work out area 2? It is 4 over 3 to 0. And that's what 3x squared take away 4x dx. 3x squared take away 4x dx. Okay? Off you go. Can you work out these areas or these integrals to begin with, and then we'll see where we are. So for the first one, you get 32 over 27?
Yes.
And the second one?
Minus 32 over 27.
Alright. What we want to do is the integral is negative for the second one. The integral is negative. But the area is positive. Yeah? So therefore we can say the area of A1 is 32 over 27. The area of A2 is 32 over 27. And therefore be very clear and say therefore the total area, or I should really say the total shaded area, is 64 over 27. But bear in mind, this doesn't mean you've got a negative area. We can't really have one. This means it's a negative integral. Okay, not a negative area. You've got a negative integral.